Okay, so yesterday we completed example 1, and so you should have been able to do the first 4 questions on P4, but I did want to go ahead and run through a couple more of the multiplying examples just to discuss some strategies that can help you out. And of course, we're also being asked about the roots, which we haven't had to deal with prior to yesterday. So I did want to also discuss things like this quadratic factor right here, that kind of thing. So on example 2, we're actually going to skip this particular one because it doesn't actually offer any additional information over what example 1 did and what example 3 is about to do. Because this is already a quadratic, and so all you would have to do is just take this linear factor and just multiply through this quadratic, and you'd have your equation. Okay, as far as the real roots, we're actually going to address basically an identical situation here on example 3. So that's actually where we're going to start today, is example 3. Before we multiply it out, we want to go ahead and we want to find our real roots. So we've got 3 factors. Our first factor is the negative x at the beginning of the equation, and so it tells us that x equals 0 would be one of our roots. And then our next factor is the x plus 8, and it tells us that x equals negative 8 would be another root. And then as far as knowing whether or not you're going to have any more real roots, this last factor is a quadratic, and it's actually not going to give you any additional real roots, but the way that you would be able to tell that for sure is you would have to remember back in our quadratic unit, we discussed something called the discriminant, b squared minus 4ac, from the quadratic formula. And what that discriminant tells you is the number and nature of your solutions. So we plug in b, a, and c, and what it tells us is whether we're going to have 2 real roots, 1 real root, or no real roots, because our numbers would be complex. And so if I plug the numbers in here, now most of the time we don't bother showing this work. I'm just showing you mentally kind of what you would run through. So a is 1 and c is 64. So what this quadratic here is telling you is that you would have a 64 minus, and remember I'm talking about doing this mentally, right? So you're mentally looking at this, and you don't want to actually have to multiply 4 times 64 and actually do the subtraction, but we know that this number is going to be a whole lot bigger than this number. And so we know mentally that we would have a negative inside of our square root, or a negative for our discriminant. And what that means is that there's no real answers to this quadratic right there. And so what that means is that over here, x equals 0 and x equals negative 8 are the only 2 real roots for our polynomial. Okay, and so that's something that you do separately. It doesn't actually have to do with the multiplying process. So I'm going to go ahead and erase so that I can go ahead and actually do the multiplying now. Okay, and so we've got our real roots taken care of. And so now what I want to do is I want to actually go ahead and multiply this. Now, I'm going to go ahead and tell you that this is going to produce a special factoring pattern, because these right there, it's a plus b, and then a squared minus ab plus b squared. So it's a sum of 2 cubes. Now the thing is that it's really hard to recognize that. Even math teachers, most of the time we don't bother recognizing that pattern in that direction. We just go ahead and do the multiplying. Okay? But what we then know would happen is that when these 2 factors multiply together, we would just get a cubed plus b cubed. So what's going to happen is it's going to become a much smaller equation. A bunch of stuff is going to cancel out. Okay? Now, like I said, most of the time you don't know that going into it, and you don't look at these equations and recognize these factoring patterns when you're going this direction. Normally what will happen is you're going to go ahead and just multiply this equation out like you normally would, and what ends up happening is that stuff just starts canceling. Okay? And so normally the way you would go about doing this problem is you would take these two factors and you would multiply them together first. And so what would happen when you do that is you would get negative x squared minus 8x. And then what you would do is you would use one of the long multiplication methods we looked at yesterday, and you would now multiply this quadratic times this quadratic. And so you would use your long multiplication, your box method, or your distributive property. Now, because of space constraints when you're doing this on an iPad, I'm going to go ahead and just use the distributive property. So what I'm going to do is I'm going to take the negative x squared, and it's going to distribute through the other parentheses. So when I distribute it, negative x squared times x squared is negative x to the fourth. Negative x squared times negative 8x is positive 8x cubed. And negative x squared times 64 is negative 64x squared. So I've now multiplied that one through. And then I take the negative 8x and I distribute it through the parentheses. And so negative 8x times x squared gives me negative 8x cubed. Negative 8x times negative 8x gives me positive 64x squared. And negative 8x times 64 gives me negative 512x. And so sure enough, what's going to end up happening is when I combine my like terms as my last step, negative x to the fourth doesn't have anything to combine with, but the positive 8x cubed and the minus 8x cubed cancel, and the minus 64x squared and the plus 64x squared also cancel. And so the only other term I'm left with is the minus 512x. And so that's the polynomial you get when you multiply example 3 all the way out. Okay? And then example 4 is the final type that we're going to do of our multiplying out problems. But of course, before you do the multiplying out, you want to find the real roots because it's already factored for you. So your first factor is x plus 1. And the root it's going to give you is, of course, negative 1. Your next factor is the x plus 5. And so it's going to give you x equals negative 5. And then remember, this is a squared factor, so that's the same thing as that factor occurring twice. So you can either actually list it twice. We're going to have x minus 3 twice. And that means we're going to get x equals 3 as a solution twice. Or what we also do is, I'm going to write or because I don't want you thinking this is additional answers. You can also say x equals 3 is a solution with something called a multiplicity. It's got a multiplicity of 2. Now we're actually going to discuss multiplicity here in the next day or two, but I just wanted to introduce you to it. And of course normally we abbreviate it, but the abbreviation wouldn't have made any sense since you guys had never heard the word to begin with. So this is just another way of saying the same thing, that x equals 3 is a solution twice. So there's all your real roots because it was already factored. And then as far as the actual multiplying out process, normally what we would do is, of course, we would recommend that you go ahead and just rewrite that x minus 3 again. And remember what step 1 said yesterday. Step 1 said multiply your pairs of factors. So what that means is normally you would take the first two factors and FOIL them together. Okay, and a lot of people can just do that mentally. So if we FOIL those first two factors together, we would get x squared plus 6x plus 5. And then we would take the second pair, or the final two factors of our equation, and we would FOIL them together, and we would get x squared minus 6x plus 9. And so now that we've got the first couple of pairs of factors multiplied together, now what we need to do is we need to use our long multiplication to do the two quadratics multiplied together. Okay, and so I think I've got the space. I'm going to go ahead and just make sure I have adequate space to go ahead and do a different method just to make sure that we are showing a variety of methods. I'm going to go ahead and actually do my long multiplication. So I'm taking this quadratic times this quadratic. Okay. And so my first digit is going to be the plus 9. So when I multiply it across, I'll get plus 45. I'll get plus 54x, and I'll get positive 9x squared. Okay, and that takes care of that digit, and then of course I put a 0 there. Then I would take the negative 6x and multiply across. So negative 6x times 5 gives me negative 30x. Negative 6x times positive 6x gives me negative 36x squared. And then negative 6x times x squared gives me negative 6x cubed. And then I would put 2 zeros there. And then the last one, I take the x squared and multiply across. So I get 5x squared. I get positive 6x cubed. And then I get positive x to the 4th. And now I can add straight down, and all my like terms are ready to combine. They're all lined up with each other. So I have my x to the 4th. The cubic terms cancel. When I add up all of my quadratic terms, I end up with minus 22x squared. Add up all my linear terms and I get positive 24x, and then all my constants add up to 45. So my equation, h of x, is x to the 4th minus 22x squared plus 24x plus 45. Okay, and so that's all the multiplying problems that we're going to do. Okay, so you just need to make sure that you can do those. And I'll post this to my YouTube channel too, so you can always come back and watch this video again and pause it and try the problems for yourselves and that kind of thing. So now, these last couple problems we're going to do before the quiz are example 5 and 6, because they do a great job practicing our factoring too, because remember there's 2 factoring problems on your quiz today. Okay, so remember, of course, the first thing you always want to do when you're factoring is you always want to see if there's a GCF to pull out. So that's the first thing that we're going to do. So on example 5, the GCF is a 16x. When we pull the 16x out, we're left with x cubed minus 8. And so this problem also allows us to review one of our special factoring patterns, because x cubed minus 8 is a difference of 2 cubes. It's a cubed minus b cubed. And remember that you need to actually know the factoring patterns. They're not provided for you on the quiz. A cubed minus b cubed factors as a minus b, and then a squared plus ab plus b squared. So what that means is, in the case of this factor right here, this is an x that's been cubed and a 2 that's been cubed, so that means your first factor is x minus 2. And then your second factor for that cubic would take the x and square it, so x squared, and then a plus sign, and then the x times the 2, so 2x, and then a plus sign, and then the 2 squared. Okay, so here it is, it's completely factored. So as far as your quiz today, that problem would be done. What we're going to start doing now is, once we've got it factored, then we can use those factors to give the real roots. So 16x is your first factor, and the root that it would give you, or the solution that it would give you, would just be x equals 0. X minus 2 was the second factor, and so the solution it would give you would be x equals positive 2. And then this final factor, this one right here, is another one of those quadratics where if you try to solve it or if you do the discriminant for it, what you'll see is that it gives you no real roots again. And so what that means is the only two real roots for our equation are 0 and 2. Okay? So that was a good review of make sure you do your GCF first when you're factoring, and then you do need to know your patterns. Okay? And this last problem we're going to do actually also goes over some important stuff. Of course, the first thing it's going to go over is it's going to go over the grouping method. So that's the first thing it's going to go over. And then it's going to give us another factoring pattern here in just a minute once we've grouped it and started factoring. Okay, so let me go ahead. Okay, so if I start my grouping, if I group the first two terms and group the last two terms, the GCF for the first group is a 4x squared, and it leaves behind an x plus 10. And then the GCF for the second group is a -1, and it also leaves behind an x plus 10. And now this group and this group have a common factor, and that common factor is the x plus 10. So you pull that x plus 10 out, and when it's gone from each of the two groups, you're left with a 4x squared minus 1. Okay, and so then the second thing that this problem reviews is another pattern, but this one's easier to spot and it's one we've been using longer. This right here is a difference of two squares. So we've already got our x plus 10 pulled out, and 4x squared minus 1 would factor as 2x plus 1 and 2x minus 1. So once again, as far as your quiz goes today, that problem would be done. Okay, but now what your homework tonight is going to ask you to do is it's going to say take each of those factors and tell me what real roots it gives you. So x plus 10 gives us a root of -10. 2x plus 1 gives us a solution of -1/2. And 2x minus 1 gives us a solution of +1/2. And so there's our three real roots from that equation. Okay. The last two problems don't generate any additional practice. It's, you still have your GCF, you still have your special patterns to look for, and so they're really not going to teach you any new material. So for the sake of allowing you plenty of time on your quiz, we're going to go ahead and shut it down for now. And so now you should have the ability to finish your P4 homework tonight. Okay, so all you have to do now is your quiz, and then you don't have anything to pick up because you already got the homework assignment yesterday. So thanks a bunch, guys.